This is problem 24 of chapter 10 of Giancoli 6th edition. So the problem says that a crane lifts steel hull, and they give us the mass of this steel hull, okay? And so steel, that means we also know the density. I just need to go to a table to find it, okay? And so it holds of a ship which is inside the water, okay? And well, they don't tell us, but we are assuming that this water is just water at 4 Celsius. Okay, so we also know what is the density of the water. And we want to know what is the tension in the crane's cable when the hull is submerged in this water. Okay, so here we are. We have this object inside the water. We are trying to lift it, so we have here some tension force. We have the weight of this object, and since it's inside this fluid, we also have buoyant force. Okay? And we want to know what is this tension force. Okay, so I'm going to use this reference frame, and the tension force, well, let's see, let's write the sum of all the forces. Ft plus the buoyant force minus mg equals to 0. Okay? And from here, I should be able to find Ft, the tension force. So what is going to be? Ft is the mass of this hull multiplied by g, so the weight of this hull, and this we know, and minus the buoyant force. Now, what is the buoyant force? Let me write this whole thing again. The buoyant force is the density of the fluid, and this is water, 10 to 3 kilogram per cubic centimeter. The volume of the water, which is also the volume of the fluid, so the volume of the water that was displaced so that this fluid could, so that this object could be there, and this multiplied by g. Okay, so it looks like we almost have everything apart from the volume of the object, which is not given. But don't panic. Whenever a volume is not given, try to look for the densities. Okay? What do we know about the density? We know that the density of this object is the mass of the object divided by the volume. So what we can do is, instead of writing the volume of the object, we can write the volume of the object is the mass of the object. This one we do have is the mass of the hull, right? Divided by the density of the object. This one we also have because it's density of steel. Okay, so with this we will now be able to find Ft. So Ft is the mass of the hull, which is given to us, G, we know, minus the density of water, we know. The volume is now going to be, again, the mass of the hull divided by the density of the hull, which is density of steel, multiplied by G. And from that, we get then Ft. Okay? Now, for part B. Part B of the problem says, what is the tension when the hull is completely out of the water? That's much easier. Now, in this case, now we do not have buoyant force, so the tension will just be the mass of the hull, G, just the weight of the hull.